Alright, lesson 5.4 gets into a lot of vocabulary when it comes to graphing functions and the graph of functions. So the name of this lesson is Graphical Features and Terminology, and your aim today is that I can use a variety of mathematical vocabulary to describe graphs. So the major focus of this lesson is vocabulary and describing graphs. Okay? So, there's a lot of terminology associated with a graph of a function. Many of the terms have names that are descriptive, but still work is needed to master the idea. This lesson only has 2 exercises. We have exercise 1, you'll notice it goes all the way to question F, and then you have exercise 2 on your second page. So, we're going to talk about just 2 different graphs and answer some questions about both of them. So, let's look at exercise 1. The function y equals f of x is shown, graph below, over the interval -7 to 7. This notation right here means that it starts at 7. It starts at 7. And it ends at 7. So notice if we go to my graph, I go 1, 2, 3, 4, 5, 6, 7. I have gone to the left 7, so I'm at -7. And then I've gone to the right 7. So that's why this graph is from -7 to 7, because the ending point's -7, and the starting point's -7, and the stopping point's +7. Okay? So let's look at letter A. Find the maximum and minimum values of the function. So maximum value, again, we talked about this in the last lesson, it means the highest. So if I go to my graph, this kind of looks like hills. So you want to kind of find the highest hill, the highest point, which is right here. So this is my maximum. The point I can write as a coordinate. That's the coordinate -1, 1, 2, 3, 4, 5, wait, sorry. 1, 2, 3, 4, 5, 6, 7. So the point is -1, oh my gosh, -1, 7. So that's my maximum. My minimum is the lowest point this graph occurs. So I'm going to underline minimum and find the lowest, and that is right here. That's my minimum. It's the very smallest point, and that's at the coordinate -1, 2, 3, 4, 5, -1. So my minimum is -5, -1. So minimum, maximum. Pretty simple ideas. You want the highest one and the lowest one. In fact, I'm going to write that down here just to help you guys out. So maximum is your highest and minimum is your lowest. Okay. Question B. What is the y-intercept of the function? Okay, y-intercept is an interesting concept. Y-intercept, and I'm sure this isn't the first time you've heard this, the y-intercept is where the graph crosses the y-axis. So here's my y-axis right here. It's the one that goes up and down. Where does this graph intersect it? Right there where my blue dot is. That point is my y-intercept. And that is at the point 0, 1, 2, 3, 4, 5, 6. Okay. So now we've had 3 words to think about: maximum, minimum, and y-intercept. The next thing to think about, and this is really, really important as well, are your x-intercepts. So, your x-intercepts, hopefully you can see the yellow, are where the graph touches the x-axis. So here's my x-axis right here, where I circle on the right in yellow. And now I need to find out where this graph touches the x-axis. Now there can be many of these, right? That's why it says plural zeros. So I'm going to look at this graph wherever it touches here. So I'm going to keep looking, oh, here, there's where it touches, and there's where it touches. So notice if I keep trying this yellow line, it doesn't touch the graph anywhere else. So those 2 points are right here. So that's at -1, 2, 3, 4. So -4, 0, and 6, 0. So those are my two zeros. We also call them x-intercepts, where the graph crosses the x-axis. We call them zeros because the y value, notice, is 0 no matter what your x value is. Okay? So now I've got 4 words. We have maximum, minimum, y-intercept, and x-intercept to think about. Letter D. Would you characterize the function as increasing or decreasing on the domain interval -5 to -1? So this is saying, hey, look, if I'm starting at -5 and ending at -1, so I'm going to go to my graph and find -5, and keep in mind it's the x. So 1, 2, 3, 4, 5. So here is -5. I drew a line through it. And then here is -1. We're looking at this interval right here. Is this increasing or decreasing? Increasing basically is what it sounds like. It's going up. Decreasing means it's going down. Is this going up or going down? Are these getting bigger or smaller? It's going up. So we call this an increasing interval. This is increasing. Okay? I'm going to explain it by saying because the function is getting bigger y values. Notice as I go from -1, the y is increasing. Right? I'm sorry my pen's writing is so terrible. I'm getting a new pen for Christmas, hopefully, so this pen won't be so bad. I'm not sure why it's doing what it's doing. So, bear with me. Letter E. One additional so this should say, I think, name. One additional interval over which the function is increasing and one over which it's decreasing. So I'm going to look on my graph and I see that I have an interval. I'm going to go here on my pen. This is right here, a decreasing interval. It's starting here and going down. So I'm going to say that starts at 1, 2, 3, 4, 5. So it starts at 5. And it goes all the way to 7. So there's a decrease interval. From 5 to 7, it's decreasing. Now I can go to this one right here, and to here, and this is increasing. There are other ones I could have used besides these two, but these two both were easy. So increasing is here, and that starts at 2, and it goes all the way to 5. And my notation looks very similar to notation from Unit 4. I'm using these to show that I start in the left one and I end on the right one. Okay? Alright, so we've talked about, now to sum up, we've talked about maximum minimums. We've talked about y-intercepts, x-intercepts, and zeros. And we've talked about increasing and decreasing. Finally, letter F says we're going to define a couple things as a relative minimum or maximum, and they're called turning points. So F says the following points are known as turning points. Each can be classified as a relative maximum or a relative minimum. State which you think each is. So I'm going to go to my graph, and I'm going to erase this. You can always go back and recopy it, but there's too much color on here, and I want to be clear about what a turning point is. So I'm erasing all of this. And we're going to look at these points here. I'm going to put them in blue. So the first point is this -5, -1. That's this point right here. The second point is -1, 7, right there. We have 2, 2, which is right here. And we have 5, 5, which is right here. These are all called turning points. Look at the graph. Do you see how each of those points, that's where the graph suddenly goes from an increasing to a decreasing, or from a decreasing to an increasing? That's why they're called turning points. It's a place where the graph turns. Each of them can be classified as a relative minimum or maximum. So it's kind of simple. If it's going down and then going to up, such as this first one, we're going to call that a relative minimum. So this 5, -1 is a relative minimum. However, on the second one, -1, 7, this top one right here, that is a relative maximum. Okay? So this is a relative minimum, and this is a relative maximum, and here is another relative minimum, and here's a relative maximum. So think of it like hills, like I said, in valleys. Minimums are valleys, maximum are hills, is one way to think about it. So 2, 2, this is a relative minimum, and this is a relative maximum. So we can write this relative minimum here as a, in fact, I'm going to help you do this. I'm going to say that a relative maximum is saying a hill, and a relative minimum is like saying a valley, to help you get an idea of what these words mean. Okay? Alright, let's do some more practice on exercise 2 with all of these. So we're going to work in this exercise another piecewise function, which we talked about in the last lesson. So remember, piecewise defined functions have the two definitions, two equations, based on what x is. So consider the piecewise linear function given the equation f of x equals x plus 3 if x is less than 1, and 6 minus 2x if x is greater than 1. So the first thing I'm going to do is I need to split up these two equations into my table. So I'm going to make this first one purple, and this says that x is less than or equal to 1. So I'm going to go to my table, and for all of these values here, I need to use the equation x plus 3. Okay? Because these are all my values where x is less than or equal to 1, and that's the equation x plus 3. Then I need to take a look at my second equation, which is 6 minus 2x, and that works when x is greater than 1. So I'm going to have here, and notice that 1 is included in both. It doesn't really matter for this one because the equations turn out to be the same. So I'm going to have, 6 minus 2x for this one. And like I did in the lesson before, I'm going to make my table of values by plugging something in. So this is x plus 3. And my other one is 6 minus 2 times x. So I'm putting parentheses where I'm going to plug in my inputs. Now I can plug in my input. So I have a negative 4 here, negative 3 here, negative 2, negative 1, 0, and 1. And for my second equation, I have 2, 3, and 4. So I'm plugging in my inputs, and now I'm going to calculate and get my outputs. So negative 4 plus 3, that's just a negative 1. Negative 3 plus 3 is a 0. Negative 2 plus 3 is positive 1. Negative 1 plus 3 is 2. 0 plus 3 is 3. And 1 plus 3 is 4. So that was pretty simple. This will be a little bit more challenging. 6 minus 4 gives me a 2. 6 minus 6 gives me a 0. And here, 6 minus 8 gives me a negative 2. And now I'll go write my coordinates. This is the coordinate negative 4, negative 1. This is negative 3, 0. This is negative 2, 1. This is negative 1, comma 2. And again, my pen is doing this thing where it connects the numbers, and I'm not really sure why it's doing that. 0, 3. 1, comma 4, 2, comma 2, and 3, 0, and finally 4, negative 2. So here I've created all of my coordinates, and now I'm ready to start graphing my points. So let's make our graph. The first one is at negative 4, negative 1, which is here. Negative 3, 0 here. Negative 2, 1, so these all are going up in a straight line. Negative 1, 2, so I'm right here. 0, 3, that's that one. 1, 4, that one. 2, 2, 3, 0, and 4, negative 2. So my graph looks like this. Alright. Okay, so that's the first thing it wants me to do is graph my point, so I'm done there. Let's take a look what the questions are. So this first question says state the zeros. Alright, well I just talked about in exercise 1 that zeros are the same as the x-intercepts. So that's where does the graph hit the x-axis? Well, here's my x-axis. Where does the graph hit? It hits it here, and then it hits it again here. So those are my x-intercepts. So those are at the points 3, 0, and -3, 0. Now, I know that easily because I know that an x-intercept is wherever y is 0. So even without looking at the graph, I could have looked at my table here and seen that those were my two x-intercepts. Just because I know that those y values have to be 0 to be an x-intercept. Alright? C. State the function's y-intercept. Well, a y-intercept, like an x-intercept, is where the y is 0. So I'm going to look at my y, and boom. Right there is where it hits the y-axis. And that's at the point 0, 3. And again, because the 0 is here, I could have seen that from the table as well. Okay? Letter D. Give an interval over which the function is increasing and give an interval over which the function is increasing. Technically, in this graph, there's only two intervals where there's increasing and decreasing. There's this one where it starts here and ends here, and then a second one where it starts here and ends down here. So this is the decreasing interval, and the purple one is the increasing interval. So the purple one starts at -1, 2, 3, 4. So -4. And it ends at, we're looking at x values now. So it ends at here, which has an x value of 1. Okay? Decreasing, it's my yellow. It starts at 1, like the other one ended. And it's going to end at right here, which is a 1, 2, 3, 4. So there's my increasing interval and my decreasing interval. Okay. Letter E, give the coordinates of the one turning point and classify it as a relative maximum or minimum. Well, this one's pretty simple. The only turning point on this whole graph is this top point right here. That's my turning point. And I'm really, really sorry about my pen, guys. I don't know why it's doing this. So there's my turning point. Let me try and write that one more time. Alright, I give up. Okay, I'm going to write it messy because I don't know what else to do here with my pen. So that's the turning point, and that turning point coordinate is at 1, 4. And is this a maximum or minimum? It's a relative maximum because it's a hill. It's the highest. Okay? I think we have one more question. F. Use your graph to find all the solutions to the equation f of x equals 2. Illustrate your solution graphically and find evidence in the table you created. So this is a fancy way of saying where y equals 2. Remember, f of x means your output. So where are all the outputs to? Where are all the y values to? So I'm going to scroll up here, and I'm going to redraw this graph for you guys, just so I can get a fresh plate, so we can take a look at this a little better. So give me 1 second to redraw. And then it goes here, here, and here. So I just redrew the graph. So now the question is saying find out where f of x equals 2. So with my blue pen, I'm going to take a look at the graph. And okay, so where's f of x 2? Right there. So I'm going to draw a line through the graph, and any point the graph touches is a solution to where y equals 2. So there and there. This is the point 2, 2, and this is the point -1, 2. Notice that both the y output is 2, which is why these are a solution. So my answers are -1 and 2 is where it's a solution. So when I go down to answer the question, I'm going to say, okay, f of x equals 2 at x equals -1. Again, this pen. At x equals -1 and x equals 2. I could write the coordinates also, so I could put -1, 2, and 2, 2. Okay? And finally, G, state the interval over which this function is positive. How can you tell this quickly from the graph? A positive, if I'm looking at the graph and I'm trying to think of positive, again, I'm going to erase this to try and show you guys positive as much as I can here. We're looking for where the graph is positive. Positive is this half of your graph when it's positive. Okay, so that is all positive. So if I want to look at where this graph is positive, I'm going to use the x-axis to cut it, and starting here and ending here is where this graph is positive. So my start is at -3 and it ends at +3. That is where my graph is positive. This is positive and this is positive. These two things right here, those are negative. They have negatives with your y's. So when I answer this question, I'm going to say, okay, well, it's positive from -3 to -3. Alright? So a lot of vocabulary in this lesson. A lot. We talked about maximum minimums. Let's go back and review. We talked about maximum minimums. We talked about y-intercept, where the graph hits the y-axis. We talked about x-intercepts, where the graph hits the x-axis. We talked about increasing and decreasing and how to notate that. We also talked about turning points and how those are going from valleys to hills and being relative minimum maximums. And then finally, we also talked about the very end here, we talked about a function being positive. Okay? Alright, mastery for 5.3 and 5.4 is combined, so make sure you memorize the vocabulary for this. Okay, this is a memorizing kind of lesson in describing a graph. Okay, so if you have to write things down, make yourself flashcards, that might be a good idea. Alright, good luck.